Writing linear equations in standard form. This lesson will define what a standard form is. We'll write equations and we'll graph. Standard form of a linear equation is in the form of ax plus by equals c, where a, or the leading coefficient, must be a whole number. So that means it cannot be negative. B and c must be integers. So we have no fractions, and the leading coefficient must be a positive number. Example 1. Transform each equation into standard form. Y equals 1/4 x minus 3. So this equation is in slope-intercept form, and we're going to rewrite it into standard form. So the first thing we're going to do is get rid of the denominator because we can't have fractions in standard form. So we're going to multiply the entire equation, each term, by 4, which will leave us with 4y is equal to x minus 12. We're now going to move the x to the left side by subtracting it on both sides, and that leaves us with negative x plus 4y equals negative 12. Remember, standard form is ax plus by equals c. So we can't have a negative number here, so we need to divide each term by negative 1, which will leave us with x minus 4y equals 12, which is standard form. Y minus 4 equals 3 times the quantity x plus 2. This equation is in point-slope form. We need to transform it or rewrite it into standard form. So the first thing we're going to do is distribute, which leaves us y minus 4 equals 3x plus 6. We're then going to add 4 to both sides, which leaves us with y equals 3x plus 10, which is slope-intercept form. We're now going to continue and write it into standard form. So we're going to subtract 3x from each side, which will leave us negative 3x plus y equals 10. Since the negative 3 is the leading coefficient, it cannot be negative, we need to divide each side by negative 1, which will leave us with 3x minus y is equal to negative 10. Example 2. Write an equation in standard form for the line graphed below. So here we have the line, and from this graph, we can write this equation in slope-intercept form, which is y equals negative 2/3 x minus 1. So now we're going to continue and rewrite this in standard form. So the first thing we need to do is to multiply each term by 3 to get rid of the denominator, which leaves us with 3y is equal to negative 2x minus 3. We're going to add 2x to both sides, and that's going to leave us with 2x plus 3y is equal to negative 3. Alright, so again, here we have a graph, and we're going to write it in standard form. We're going to start by writing the equation of a line in slope-intercept form. So y equals 1/5 x plus 3. I'm going to multiply each term by 5, and the result will be 5y is equal to 1x plus 15. I need to move the x over, which will leave us with negative 1x plus 5y is equal to 15. And since I can't have a negative for the a, the coefficient there, I need to divide each side by negative 1, which leaves us with x minus 5y is equal to 15. So now we're going to graph. Example 3, graph the equation below. 3x minus 6y equals 18. One way we could do this is rewrite it in slope-intercept form, and then graph the equation. So when we rewrite this in slope-intercept form, y equals 1/2 x minus 3. Another way we could graph using standard form is graph using the x and y intercepts. So instead of rewriting a slope-intercept form, since this equation is in standard form, I could easily calculate the x and y intercepts. So my x-intercept is 6, or crosses the graph at 6, 0, and my y-intercept is -3, which crosses the graph at 0, -3. So in this instance, you could graph either way, and actually by graphing using the x and y intercepts was probably faster. X plus 4y equals 12. So rewrite using the slope-intercept form. Now if I look at this equation and wanted to graph the intercepts, if y is 0, x is 12. So this would be the x-intercept would be off my graph. So I may choose in this instance to go ahead with the slope-intercept form. Unless I had a really big graph, then I could go ahead and do my intercepts, where x would be 12 and y would be 3, -3. 3.